Welcome to Nios Studio. I am Dr. V.P. Joshit from Central University of Kerala. Today, we will discuss about concept and forms of scientific inquiry. Inquiry, it's a very important term in science. What does inquiry say? Here, students are in control of an important part of their own learning, where they can manipulate ideas to increase understanding. See, the definition of inquiry, which has been given by National Science Education Standards. Inquiry is central to science learning. Students engaging in science inquiry will demonstrate the following behaviors: describe objects and events. Again, they are able to describe the objects that they come across. They are able to just remember or to say about the events that they know. They ask questions. They construct explanations. They test explanations against current scientific knowledge. Whatever the explanations that they have made, they will just check against how these explanations go with the body of knowledge, how these explanations differ from the scientific knowledge. Now, they communicate their ideas to others. Whatever they understand, whatever they comprehend, these things can be communicated to others. They identify their assumptions. They use critical and logical thinking. Again, what we use critical and logical thinking? We use critical and logical thinking for solving. They consider alternate explanations. So, these are the sets of behaviors which has been given by National Science Education Standards, where they say these will be demonstrated by those people who just go with scientific inquiry. Now, again, we come across the term inquiry. Inquiry as the creation of a classroom where students are engaged in essentially open-ended, student-centered, hands-on activities. The definition has been given by Alan Colburn. See, again, students are engaged in open-ended questions. Again, student-centered questions, because whatever which come in their mind will be an output, will be just given as a reflection. Then how do they just have a hands-on activities. They just try each and everything in the class so that they can give whatever the output it is. So, this has been the definition of inquiry given by Alan Colburn. Now, we will see what are the approaches to inquiry based instruction. Again, this classification has been given by Colburn. They are structured inquiry, guided inquiry, open inquiry, and learning cycle. So, the four important things, just I repeat: the structured inquiry, guided inquiry, open inquiry, and learning cycle. Now, we will see the steps in inquiry. In general, we have three important steps in inquiry, that is question, investigate, communicate the results. So, the steps are question the thing, investigate the thing, then whatever you find out as a part of your investigation, you just communicate to an audience. So, this is the steps in scientific inquiry. Now, scientific inquiry. Scientific inquiry progresses through a continuous process of questioning, data collection, analysis, and interpretation. So, again, we have four important processes. One is questioning, another one is data collection, another one is analysis, and the last it is interpretation, which we call it as analysis and interpretation together. Scientists use three types of investigations. One is descriptive investigation, another comparative investigation, and third one experimental investigation. So, first they just go for description, they describe each and every characteristics, they describe each and every point so that they investigate something new from that. They compare with the existing one, they just see the similarity, they just see the differences and they just go for investigation. So, comparison is a mode of investigation. And last one, obviously it is science, we go for experimental investigation. So, we have three different types as we have seen, like descriptive, comparative and experimental investigation. What is science inquiry? The science inquiry is the way of understanding the unknown. Those things which we are not familiar, those things is above our mind, those things is above our perception, which we try to understand from the existing things. This is the way of understanding the unknown. This is a stepping stone of scientific processes. We go for many different scientific processes, and scientific inquiry is a stepping stone of many different scientific processes. It is the methods by which questions are answered. Again, as a student of science, many different questions which come in your mind. So, you have to respond to question and you have to ask question. So, how a person answers to a question based on the syntax, based on the logic he applies, which we can call it as a step or a stage of scientific inquiry. It is a thoughtful and coordinated attempt to search out solution. Again, we say that scientific inquiry is a thoughtful process, it is a coordinated process, and here on thoughtful coordination we come out with solution. That is what is scientific inquiry. Now, we just see what are the features of scientific inquiry. Here, learner engages in scientifically oriented questions. Learner is always related to the questions which are normally scientifically in nature. Learner gives priority to what? Priority to evidence in responding to questions. Again, as a person of science, we never give priority to hearsays. Always the learner gives priority to evidence in responding. Learner formulates explanations from evidence. Again, we have some evidence. Based on the evidence that we have in our hand, we just formulate our explanations. Learner connects explanations to scientific knowledge. Again, each and every explanation has been connected, like it is a concept, concept will be linked to make it as a principle, make it as a theory. So, all these things will be connected and finally we come up with scientific knowledge. Learner communicates and justifies explanations. So, whatever the explanation that he has given, and if he receives any criticism on that, and he just justify each and every point of his communication, that is what is scientific inquiry. Now, we just go through the objectives of scientific inquiry. Scientific inquiry is flexible rather than involving one particular method. See again, teaching science through scientific inquiry is the cornerstone of good teaching. So, what we have told, it is flexible and it is not like involving only one particular method, and it is the cornerstone or it is the essence of good scientific teaching. The most traditional model of conducting scientific inquiry is known as scientific method. So, again we come with a new term. The term is known as scientific method, relatively similar, but it is again new. The scientific method is a process for experimentation that is used to explore observations and answer questions. So, it is a process of experimentation which we use to explore observations and answer questions. A process like the scientific method that involves such backing up and repeating is called iterative process. So, scientific method has got a backing up process and we just do each and every step repeated because we want to get final proof, we want to prove, and such process which we do like this, which we can call it as iterative process. Now, we just have these steps of scientific inquiry process. First, identify the problem or question. We have the problem or we have some questions, you do identify the question, which becomes the first part of scientific inquiry. Collect background information related to the problem. Again, we just go like a review. We want to get each and every information related to the problem, which we call it as background information. Form a hypothesis. What do you mean by hypothesis? Hypothesis is a tentative solution. Hypothesis is our guess. Hypothesis is our intelligent guess. After that, with reference to the hypothesis that we have formed, we just test the hypothesis. So, testing the hypothesis is another stage, and after testing the hypothesis, we just analyze our results. What are the results that we have got? We analyze each and every one. After analyzing the results, we draw conclusion and we communicate the results. So, identify, after identifying, collecting background information, then we are framing hypothesis, after that testing hypothesis, after that analyzing the results, after that just what we do, we just communicate, we just have the interpretation, we just draw inferences, and after drawing inferences, we just communicate. So, these are the processes of scientific inquiry. Now, see, first one, identify the problem or question. Here, careful observations lead to questions. Scientific questions must be precise. There are 5 categories of questions that science cannot answer because they are not testable. They are values, aesthetics, morality, religion, and supernatural. So, all these 5 like values, aesthetic, morality, religion, and supernatural, there we do not go for any scientific testing. Second, see, collecting background information. Here what we do? Gather the existing facts and ideas from books, journals, previous studies, reportings, internet, all those sources, and provide insight regarding our problem in question. Again, here we go for a detailed review. We collect information from all the sources. Maybe they are primary sources, maybe they will be secondary sources, and after collecting information, we just give an insight to our problem or question. Now, third one, we form a hypothesis. So, the stage or the step is that form a hypothesis. A hypothesis is a prediction about the relationship between the variables that can be tested. Again, I have already told, hypothesis is a shrewd guess, hypothesis is an intelligent guess, hypothesis is a tentative solution. So, 4 important characteristics of hypothesis are: it is testable, it is falsifiable, easily measured, and usually written as if and then statement. See, hypothesis is testable, it is falsifiable, it can be measured, and we write hypothesis as if and then statement. Now, fourth stage, it is test the hypothesis. An experiment is a repeatable procedure that is used to test a hypothesis. In science, we do lot of experiments. The procedure is a step-by-step plan that indicates how materials are used and what will be done. It will also identify variables, groups, sample size, and number of trials. So, We just go for testing the hypothesis by repeated measurements or repeated occurrences. This is what is done in the case of test the hypothesis. Now, we have discussed something like variables, groups, etc. We will be going with variable. We have got some important variables, many different variables are there, but most important variables which we call it as independent and dependent. The independent variable is the factor that is purposefully changed in an experiment. So, what is independent variable? Independent variable is the variable that is getting manipulated. So, independent variable is purposefully changed. Dependent variable is the factor that is measured in an experiment. For example, as the process of change that you do in independent variable, there will be some influence on other variable which you are interested for your study, which we call it as dependent variable. A constant is any factor that remains fixed in an experiment because it could influence the results. So, what we want to do? We want to have an independent variable, we want to have the dependent variable. Whatever the change which we do in independent variable will influence the dependent variable. At the same time, we should fix something which is constant, because constants should not influence the result. Now, we will discuss about groups. We have two very important groups. They are control group and experimental group. The control group is the group used for comparison that does not receive the factor being tested, or the control group is a group where treatment is not given. Experimental group is the group receiving the factor being tested. There can be more than one experimental group in an experiment. Again, we have two things, one in which we have a common treatment or no treatment, or the traditional treatment, or which has been already established, and other in which we have the novel treatment which we are going to test. Sample size and number of trials. The sample size n is the number of subjects or objects involved in the experiment. Scientists normally conduct multiple trials. This allows them to check the results for accuracy. So, again, sample size and trials come together. We have the total number of subjects or objects which we call it as sample, and we have the total number of repeated experimentations or trials which we call it as the number of trials. Now, as research is concerned, you have to go with very important terms like validity, reliability. So, what do you mean by reliability? The repeatability of an experiment, which is known as reliability. Now, validity, the extent to which the experimental results can be generalized to other settings, which is known as validity. Again, how the results are valid, what does this result shows, which always come with validity. Reliability and validity can be increased by increasing the sample size and number of trials. So, we have told a method, we have told an understanding where you can increase the reliability and validity thereby increasing sample size and number of trials. Now, the fifth one, analyze the results. All information or data gathered during the experiment needs to be interpreted to determine its meaning. Data comes in many forms: notes, graphs, tables, measurements and calculations. Data is categorized as qualitative or quantitative. So, two different classification of data, something which involves number, quantity, which we can call it as quantitative. something which involves character, quality, which you can call it as qualitative. Now, the sixth one, we draw conclusion and communicate the results. Based on the analysis of data, conclude whether or not the results support the hypothesis. This is what we have to check. We have to check the tenability of the hypothesis, whether our hypotheses are true. Hypotheses can be accepted or hypotheses are rejected. The conclusion indicates the relationship between independent variable and the dependent variable. See, finally, what does the conclusion says? Conclusion says how much or how the dependent variable can be influenced or can be changed with the help of manipulating independent variable. Now, we just go through the advantages of inquiry learning. Inquiry learning emphasis is on the process of gathering and processing more information, allows some degrees of freedom, develops initiative and divergent thinking. It shows a sense of responsibility. Participation in inquiry activities strengthens learners' intellectual capabilities. Permanent learning happens because the learning has been generated through inquiry, so definitely the learning is permanent. Build up the learner's feeling of confidence. Again, how does you generate an output? We are generating output through our own methods, through our own strategies, through our own experimentations. So each and every point, each and every idea that we communicate will build up confidence. Now, today we have discussed about scientific inquiry, the very different processes in scientific inquiry. What does people say about scientific inquiry? The characteristics of scientific inquiry. What are the steps in scientific inquiry, starting from the problem identification to the summary where you just communicate your results. So, I think scientific inquiry has been given a detailed narration for you. Thank you.